engineering and art are like the same thing, because engineering is its own way an art form. The application of taking an idea in art and applying it to real life, that is what engineering is. Tacoma Community College offers its students with the option to take a civil and environmental engineering degree that can be used to transfer to a four-year university.
Right now, I'm taking 15 credits, the full course load, as much as I can take. For me personally, I'm interested in the material science degree, mostly just taking physics, engineering, and then chemistry classes, along with a math series.
An academic plan will look different for each person. For the most part, an academic plan will follow the guidelines of required credits to graduate TCC within a reasonable timeline.
And that's exactly why we recommend that students go to Ed Planning Day every quarter. We can make a customized academic plan, and that will be a case-by-case basis. My email is SKIM. If you forget, just think skim milk. So SKIM@tacomacc.edu. That's my email.
Class availability will affect when you can or cannot take a class. By your third to fourth quarter, you're going to want to start to introduce specialization classes. For example, Geology and 101.
So at TCC, we offer transfer degrees, not terminal degrees. How you will choose your additional specialization courses is going to depend on where you want to transfer. These specialization courses are Biology 221, Chem 163, CS 142, Math 254, Engineering 104, 114, 204, 224, English 235, Engineering 170, or 240.
Right now, I'm just considering the schools inside Washington that have an MS degree and are ABET accredited, and that would be WSU Pullman and UW Seattle.
I would say that by your fifth quarter, it is good to have an idea of what universities you want to apply to that are ABET accredited. University of Washington Tacoma's Civil and Environmental Engineering program is currently being considered for ABET accreditation.
You definitely want to get your bachelor's degree from an ABET accredited program. That is very important. It's an assurance to employers that you went to a program and that you successfully completed a program that is up to some level of standard, that you have learned a number of concepts that are really important to do the job that you need to do.
To prevent from having to take more classes than necessary, check out your university's website to keep up with deadlines.
Recommend that the students go directly to the website of the school and the program that you're interested in, and make sure that you have all of those really important deadlines, and then to put them on your calendar.
By your seventh quarter, if you haven't already, start gathering important paperwork to begin transferring to a university.
The math that you learn is extremely foundational to what you're going to be learning for the rest of your career.
By your eighth quarter, to stay within a 2 to 3 year timeline, I would recommend taking 3 classes per quarter.
MESA stands for Mathematics, Engineering, Science Achievement. MESA is basically here to support our students. A great way to meet people and establish those connections and really get involved in our program. And you get to develop more technical skills.
Notice that Engineering and 214 is available daytime during fall quarter.
Here at TCC, we want to reduce the cost of your education. So MESA has a book loaner program. You'll just go and you'll rent one at the start of the quarter, and then when you're done with the class, you just bring it back.
Dynamics and Applied Numerical Method classes are available daytime during winter quarter.
200 level engineering courses are offered once a year. So that's statics, dynamics, mechanics, and materials. You're just working through with your cohort, and there's a waiting list. Don't worry about the waiting list because we will take everyone.
Engineering and 225 Mechanics and Materials is offered daytime during spring quarter.
People kind of get fixated on like, well, it's heavy math, it's heavy science. These are just opportunities to like learn something new.
Engineers apply their creative assets to promote the longevity of humanity beyond their own personal lifespan by taking on the task of asking the hard questions like, how do we manage a surplus of waste in our land, in our water, in our air? How do we protect our homes from unpredictable storms? How do we arrange a system to support a certain level of weight for an extended period of time? And how do we establish trust in our infrastructure? The role of engineer has been pivotal in fast-tracking human development.
Structural engineering is a specialty within civil engineering. In this discipline, you'll learn how to design large structures and ensure that they stay functional during extreme weather and natural disasters. This discipline depends upon detailed knowledge of applied mechanics, material science, and mathematics. At entry level, you may design individual elements of a structure, such as beams and columns, but as you gain experience, you may be responsible for design and integrity of an entire system. Some well-known local examples include Tacoma Narrow Bridge, the Space Needle, and the Aurora Bridge.
Geotechnical engineering is an interdisciplinary field that applies the principles of geophysics, hydrology, and other earth sciences to solve engineering problems. Geotechnical engineers are a critical part of any civil engineering project, responsible for understanding local soil mechanics and designing sturdy foundations. Washington State is a geologically complex area with a range of complications related to earthquakes, landslides, and volcanic activity. Geotechnical engineers make sure that these hazards are well understood and design strategies to mitigate the risks.
Transportation engineering is the design of networking systems for traveling purposes and developing infrastructure to help people move between locations safely and efficiently. This discipline is changing rapidly, while cities such as Seattle have started using ITS or Intelligent Transportation Systems. With ITS technologies, Seattle transportation engineers can gather and analyze data to design safer roads, cleaner vehicles, and more efficient travel. The Link Light Rail is another example of transportation engineering in the Pacific Northwest, and when completed will travel from Tacoma through Seattle up to Everett.
Water resource engineers design our water supply systems to bring fresh water into the city. They also maintain upkeep to ensure reliability of pipelines, and also work towards sustainable practices to conserve water, such as building systems that recycle water, using practices that need less external pressure to filter water from sediment, such as forward osmosis. And finally, a sub-discipline of water resource engineers work towards engineering systems to prevent wildfires that can use up hundreds of gallons of water. Municipal engineering is a sector that combines many different disciplines of civil engineering, like filling potholes or trimming tree lines along electrical lines, Careers that are focused in municipal engineering usually fall into public works, the physical labor to carry out project plans, or government positions like insurance commissioners that make sure local infrastructure does not pose a risk to the lives of residents. Municipal engineers work with transportation engineers as well as structural and water resource engineers.
Environmental engineering is a broad field that covers much of the same area as civil engineering, but with a focus on improving the environment. This is a good choice for students interested in a non-traditional engineering career with an emphasis on the natural sciences and mitigating the ecological impacts of industry. Environmental engineering is often a separate degree from civil, though civil students at the University of Washington are free to take environmental classes as electives if they want a straight civil engineering degree but prefer an environmental emphasis. Environmental engineers in Washington find careers in water supply forecasting and control, wastewater treatment, air pollution control, green energy, and waste management. Thank you for coming to my TED Talk.